Good morning. So here we are at lesson point 1, slopes, lines, and calculator review. And I want to remind you that we went over in the freestyle delta and subnumbers and the slope formula. And so when we find the slopes of the lines containing each pair of points, what you need to know is that in a calculus class, you will need to be able to find a slope when given a graph, and you will need to be able to find a slope when given just the numbers for the points alone. So we're going to go through these examples and you'll see how I calculate it. Now, when we're doing it visually, we can see that the height here is a height of 4. Going from one point to the next, and that's going to be my rise. And then going this way, 1 2 3, that will be my run. But right away I want to notice, and it's important for you to see it, is that if I draw a dude on the left, always has to be on the left, then I see that they are falling downhill. That is going to mean that my slope is negative. And so when I go to write the slope, don't forget to write that negative. So negative 4 thirds. There we go. When we're doing it just numerically, I like to make sure that I actually label all of the subnumbers for my first point and then for my second point, because mentally it helps me put things in the right place. And then the other thing I have a tendency to do is to write down a blank form where I then fill the numbers in. And I always make sure that I write down this minus sign and that minus sign so that I don't forget that I am supposed to be taking the difference between those two numbers. So my y sub 2 is 2, my y sub 1 is 0, my x sub 2 is 4, and my x sub 1 is a negative 2. And that helps me right away at the bottom notice that I have a negative of a negative, which turns into a positive. Okay? So 2 minus 0 is 2, and 4 plus 2 is 6, and 2 divided by 6 is the same thing as reduced fraction 1/3. All right, so now I'm going to come back over here to this next one, and as I'm going across and labeling my subnumbers, I notice right away that 2 of my numbers, here and here, are exactly the same. So that means I'm going to get a 0 somewhere. But that does not mean I'm going to skip the step of actually writing them in, because it matters, is that 0 on top or is it on bottom? So let's see. It turns out the y values are the same, and so 2 minus 2 gives me a 0. And I don't even now if I want to be lazy and I don't want to do the bottom, I don't have to, because any number that goes into 0 is 0. And remember, in the freestyle, we talked about how this is a horizontal line. And then when I'm coming across here, number 4, and again, I always come in here and try to just label them really quickly because it helps your mind look at the numbers and start thinking about it. And right away, again, I notice that I have 2 numbers that are the same. But what 2 numbers are they? Let's go ahead and start filling in the form, and then very carefully, because this is very easy to make a mistake right here, I'm going to say, okay, well, I have a 5 minus a 2. Oh, well, that's not the 0. That's a 3. And here, oh, a 3 minus a 3. That's where I get 0. And again, it's very easy to make a mistake here. That does not mean that my slope is 0. It means that my slope is undefined, which is a vertical line. All right. So we have the formulas for point, slope form, slope intercept form, and general form. And here, let me zoom out so you can see them. And it doesn't matter what form we are given. When we are looking at parallel lines, we will need to identify that slope that is in that line in the equation that we've been given, or if we have to calculate the slope being given 2 points. Perpendicular lines, we again will have to identify that slope first in order to determine what the new slope that I want it to be is. And so again, visually looking at this graph, notice that here is a point and here is another point, as in it's going directly through an intersection of 2 black lines. Intersection, well, of a black line and a gray line up here. And so how many am I going up? remember 1, 2, 3, 4, and 5. And how many am I going over? 1 and 2. And so you could see that I'm saying that that slope is a 5/2. And opposite reciprocal means that you take the 5/2, and reciprocal means that I'm going to flip it. So I take this 2 and this 5 and I flip where they are. And if it was positive, I am now going to make it negative. And so that is how I do an opposite reciprocal slope. And so the new line, which I am looking at, and I want it to be perpendicular, I'm going to go through this point and I'm going to go now down 2 specifically, and then 1, 2, 3, 4, and 5. Okay, and that is going to give me my new slope, which is an opposite reciprocal slope, which is -2/5. So you're going to need to memorize these and the other ones that I gave you that we covered in the freestyle in order to be able to quickly and easily go through the basics of calculus, which fundamentally we're pretty much always has to do is to find an equation for a line that's parallel, a line that's perpendicular for various reasons. And we're going to keep going through it as we move through the year. So a line that goes through 2, 3, this is a point. I've been given 1 point, so I'm labeling them with my sub numbers, and I have a slope. And so if I remember that formula, I have y minus y sub 1, and that equals m times x minus x sub 1. All I want to do here is fill in the unknown things. Oops, filled that in wrong. I want to fill in the unknown things. And I have been told where my point lives. I've been told where my slope lives. And so I'm just going to fill all those numbers in. Ready? So y sub 1 is a 3, and m is a -3, and x sub 1 is a 2, and it turns out that's all you have to do. You really do not need to go any further than that. In fact, I really prefer that you do not. This is where you stop in a calculus class. Okay, now unless it's multiple choice. If you get a multiple choice question and it's in standard form, then you might need to go through it and put it into standard form. And I'll be doing that at various points and you'll get to see it. But for now, when I ask for the equation of each line that's described, you've determined which one of these formulas here you want to use, then you can just slap those numbers in there and be done with it. And you don't have to go any further than that. Now in our freestyle, we talked about a vertical line through -1, 2, and I'd like you to pause for a minute and try it because hopefully the more you practice, the better at it you'll get. Okay, great. A vertical line has an undefined slope, and that means that we have been dividing by 0, which means that x values are 0. And so that means that there's no change in the x values, which means I'm going to have an x equals a -1. Because x cannot change. It always has to be -1 in order for me to plug it into that formula and get a 0 on the bottom. I have to have those two numbers be exactly the same all the time. All right, so a line through -1, 2 that is parallel to the graph of 2x minus 5y equals 5 in slope-intercept form. Do you remember, how to use the trick? The trick to find the slope when it is in standard form. I showed that in the freestyle. I myself am not so good with that trick, so the first thing I'm going to do is find the slope. And if you do remember the trick, then you can move on here, right? You just fast forward, be like, I know what the slope is. All right, so I'm going to say that first of all, what I'm going to do is I'm going to minus 2x from both sides. So I'm going to have -5y equals -2x plus 5. And then I'm going to divide by -5. I'm going to divide by -5. I'm going to divide by -5. And I don't actually have to finish the whole problem because my goal here was just to identify the slope. I mean, I don't have to finish putting it into slope-intercept form. I get to just now identify the slope, which I'm going to say is a +2/5 because a negative divided by a negative is a positive. All right. So that's my first slope. And sometimes you might even say like, ooh, m sub 1, because that's my first slope. Now my parallel slope, that's going to be m sub 2. And now is the moment is where I'm deciding parallel, perpendicular, which one did I need? Turns out I need the same slope. So m sub 1 and m sub 2 are exactly the same. All right, so I'm going to call this step 2, where I'm deciding what slope I need in order to get either parallel or perpendicular. Parallel, it's the same, so I can just say m sub 2 is exactly the same. And I'm going to move on to step 3, which is where I'm actually going to throw it. Like I said, I'm going to slap it into my formula. Y minus y sub 1 equals m times x minus x sub 1. And I'm just going to throw the numbers that I have where they belong. And let's see, that slope that I found was 2/5, and so I want to throw it right here. And the y value that I had originally been given, and where I got this point right here, is a 2. So that was given information, and one of the tricks of calculus is to remember what you have been given and then try to use it at some point, because usually you've been given something. It's not extraneous. It's not something that you're supposed to forget or that you're supposed to just not be utilizing in some way. So my slope was 2/5. My slope was 2/5. My y value is 2, and my x value was a -1. And let's see here. My highlighting is not there. Oops. When I'm doing this here, what I want to mention is that I do have the negative of a negative. And if I don't, put the parentheses there, it doesn't look as good. So my goal is actually to come in and turn it into a big fat positive. And now that it's a big fat positive, I feel like I'm good. And if I had not been specifically told to put it into slope-intercept form, I could stop here. But because I want to put it into slope-intercept form, the question does ask me to do that. I'm going to distribute, and then I'm going to add 2 to both sides. So I have y equals 2/5 x plus 2/5. And whoops, I'm sorry, it was y minus 2. And then I want to add 2 to both sides. And I'm going to say, here we go, ready? Add 2 and add 2. And now I have y equals 2/5 x and plus, this is 2 and 2/5. Can I leave it as a mixed fraction like that? You absolutely can. You do not have to do anything else with it. And also, if this was calculator activated, you feel free to use a calculator to get a decimal there if you want. But honestly, just, 2 plus 2/5, it's easy enough to write down in this case. So moving on to number 8, we have a line through -1, 2, and it needs to be perpendicular now. And it's perpendicular to the graph of 2x minus 5y equals 5. Okay, awesome. I recognize this equation, and so I don't have to try and calculate the slope again. I already had the slope. Remember, m sub 1, the first slope, the given line, has a slope of 2/5. But in this case, for step 2, I'm going to say that m sub 2 has a new step, not exactly the same slope as before. Remember, I'm going to flip the x and the y. I'm going to say that I have a 5 over a 2, and instead of it being positive, it is now going to be negative. And then in terms of throwing the numbers in, I'm actually going to peek over here, and I'm going to use the numbers that I did before with the same signs. So y minus 2, except for that slope, the slope is going to be a new slope, -5 over 2, but this x plus 1 should be exactly the same. So the work you've done is kind of still prudently interesting to you. And here I'm going to highlight this slope is the only thing that changed between here and there. Okay, now I'm going to distribute, boom, boom, and I'm going to say I have y minus 2, and this equals -5 over 2 x, and this is a -5 over 2 times 1, which gives me -5 over 2. And in order to put this into general form, and this is the part where you're practicing maybe something new, hard to remember exactly what general form is. First of all, I'm going to add 2. Well, I would say add 2 to both sides, right? But I already have 5 hubs over here, and already I'm feeling hinky. I don't like fractions, and that's actually why we like general forms, because we're not supposed to have any fractions. So what can I do to get rid of fractions? Pause for a minute and think about which operation you want me to do. Add, subtract, multiply, or divide. Take a guess. You are absolutely right. I want to multiply by 2. Okay, and if I multiply by 2, multiply here, multiply there, multiply here, multiply there, there's 4 places that I'm going to multiply by 2, and that's going to make my fractions disappear. So I'm going to have a 2y minus a 4, and that equals a negative 5x and a negative 5. Ta-da! And now, what do I do to get it into general form? Let's try to move everything to the left. And I say that because I always like the first term, the x term, to be positive. And I have a tendency to try and get that to happen whenever I can. It is not a requirement now, but it was back in the day when I was in a calculus class. So here we go. A 5x plus 2y plus 1, and all of that equals 0. And that's your general form equation. This is what we'll be practicing in quite a few problems in this homework. So please put a star on this problem right here. Put a star on this problem. It's a very important problem. Do not forget how to put things into general form. And I say that because there's basically always a question, multiple choice, where the answers are in general form, and you need to do the work to get to that general form question. All right. Now, I've kind of taken up a little bit of space for number 10 here. I write big. And by the way, if you do too, don't worry about it. You're always welcome to do these problems on a separate piece of paper. You do not have to actually use the pre-printed page. All right, it says draw a graph of each line. And again, in my freestyle, we already talked about the easy way to cheat here. And so I'm just going to do my little table, my super quick, easy little cheat. And I'm not going to explain it too much. I throw a 0 in there. I'm going to get 3y equals 9, which is 3. I throw a 0 in there, and I'm going to get 2x equals 9, and that's going to be 9 halves, which is the same thing as 4.5. And now I can graph those very easily. So 0, 3 is this first point right here, and 4.5 and 0. And here, notice that my graph isn't really big enough, and that's because nobody was anticipating that I would be using this cute little trick. Boom. That's how I like to do it, okay? And I call that, method 1, which is to find the 2 intercepts, okay? And that's method 1. The other method would be to put it into slope-intercept form. If it bothers you that I'm trying to draw off the graph. Now, trust me, it does not bother me as your teacher if you draw off the graph, especially if you have the point labeled somewhere, like we have it labeled in this table. So I'm just going to look for the table. I'm going to see exactly what you meant for it to be. I'm eyeballing the shape of the graph. It looks basically what I want it to look like. That's awesome. Method 2, though, if that really bothers you, you can always put it into slope-intercept form. So these are intercepts, and this is find slope-intercept. And so I would say then that 2x plus 3y equals 9. I'm going to minus 2x from both sides. So I have 3y equals negative 2x plus 9. And I'm going to divide by 3, divide by 3, divide by 3. And I say y equals negative 2 thirds x. And this is plus a 3. And I'm going to erase this graph just so you can see how to use this information. And so I'm doing it in pink. Ta-da! There, I'm doing it in pink. I'm using that slope and that intercept. Ready? So my intercept is y-intercept is 3, and I'm going to go down to 1, 2, and over 1, 2, 3, and I'm going to mark a point, and boom. Now, did I mark a different point in this method than I did in method 1? Yes, I did, but notice, I'm basically at the same spot. Do you see? That's where I would have ended up, and so the shape of the line didn't change. All right, last example here, and this is going to go too fast. Remember what I said in the freestyle. Y equals 2 lives right here. It's a horizontal line, and y always has to be 2, and that's how I get my horizontal line. Okay? All right, we are done with this section.